I want to go through how to do the 2016 Particle Motion FRQ that we're doing this week. So I'll start by just reading out the question. It says, for t is greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals 1 plus 2 sine t squared divided by 2. The particle is at position x equals 2 at time t equals 4. So I went ahead and just wrote the equations that we were given and that we'll be using in this problem here. So let's go to part A. Part A says, at time t equals 4, is the particle speeding up or slowing down? So we should start by writing that the particle is speeding up when velocity and acceleration have the same sign. If you think about it, if someone is like riding a bike and they're riding it to the right of where they originally got on their bike, where they started riding, and they're also accelerating in the positive direction, which would be towards the right, then they'll be getting faster. If they're accelerating in the left direction, then they'll be slowing down. So what we need to do for part A is check to see if the velocity at time equals 4 has the same sign as the velocity, or as acceleration at a equals 4, or at t equals 4. So if we say v equals 4, I went ahead and did this on my calculator before this, you get 2.978, which is greater than 0. So this is like moving to the right. And then if we do v prime of 4, which just equals your acceleration of 4, this equals negative 1.164, which is less than 0. So therefore, the particle is slowing down. Okay, now let's move on to part B. Part B asks, find all times t in the interval 0 is less than t is less than 3 when the particle changes direction. So first we need to think about when a particle changes direction. Well, we know that a particle changes direction when velocity changes sign. So I'm just going to write that here. So particle changes direction when velocity changes sign. So what we need to do here is find out, well, when does the velocity change sign? But what we know is that in order for something to change sign, it has to equal 0 at some point. Because if you think about it with the example of riding a bike, if you're riding a bike moving to the right and then you suddenly start to be able to move backwards and move back to the left, there has to have been a moment, even if it's just a split second, where your velocity equaled 0 for you to actually change direction. So what we're going to do for this problem is we're going to see when velocity equals 0 between the times t equals 0 and t equals 3. So I'm going to write here v of t equals 0. And you could figure this out by looking at a graph on your calculator. This is a calculator active problem. And setting your x windows as being between 0 and 3. And you would get that this equals 0 when time equals 2.707. And so if you want just a little more proof for this, we can do a sign chart where we have 2.7072, and this is a 0. And if you plug in values that are less than 2.707, and I guess this should really be between 0 and 3, then you would get positive values on this side and see that it changes to negative values when it's greater than 2.707. So that is true. So moving on to part C. Part C asks, find the position of the particle at time t equals 0. So we need to find the position of the particle. So we need to create a new equation to do that based on what they gave us. So I'm going to start by writing the position t equals 0, so x of 0 equals, well, the only time value they gave us where they told us the position of the particle was x of 4, which they told us equals 2. But obviously we want this at time equals 0. But what you'll probably remember is this is from the fundamental theorem of calculus. So if we have x of 4, we need to add what we accumulated from 4 to 0 of our velocity, which if you do the integral of velocity, you'll get position. So you might be wondering, you're probably noticing that our limits of integration are going the wrong way. You know, the greater number is usually the upper limit of integration, but in this case, it's the smaller number. But this is the way that we can rewrite this in a way that maybe just visually makes more sense is by saying x of 4 minus the integral from 0 to 4 of v of t dt. And so that's just a way to rewrite this integral in a way that maybe looks a little better and makes more sense, because if you think about it, you have a position at t equals 4 and you want to subtract everything between 4 and 0 to find out what your initial position was. So now the last part, part D, says to find the total distance the particle travels from time t equals 0 to time t equals 3. So what we know is that distance is a type of quantity where every step counts. If you're looking at displacement maybe, then it doesn't matter where you went in between two values. What only matters is how far you are at a certain value from your point of reference. But distance, you want to account for everything that happened from when you left your point of reference to where you ended up. So the way that we can represent this mathematically is we can say that distance is the integral from, in this case, they want values from time values 0 to 3 of the absolute value of v of t dt. And so the reason this is absolute value is because we don't want anything to be canceling out like it would if there was some stuff that was positive and some stuff that was negative. We want everything to count towards this distance. And when you think about it, velocity, the integral of velocity is position, but the integral of speed, which is the absolute value of velocity, I'll just write that here, this is speed, is distance. And so when you do this integral, you should get 5.301. If I'm going to be making another video on some calculator tricks as to how you can actually do absolute value and how to do integrals and things like that on your calculator. So keep your eyes out for that video. I hope this helped you with this FRQ, and I will see you in my next video.